Hi, this is Mrs. Kidman, and in this video, we're going to be discussing how we can solve a system of two equations when one is linear and one is quadratic. Now, when we talk about solving a system of two equations, really what that's asking us is I want to figure out where do these lines cross, or where do they intersect? And those places of intersection, I can spell. Those places of intersection are going to be their solutions. That means both of these lines exist at those points. Now, these values that we're finding will be points, not just x values. So we want to find those points. So there are three different ways we can do that. We can solve by graphing. We can solve by substitution. And we can also solve by elimination. Now, these are the same three options that you have when you are solving systems of linear equations. Now we're looking at how we would do it with nonlinear equations, specifically with quadratics. So what we are going to do is in this video, we're going to cover how to do it with graphing. And graphing is pretty straightforward. You graph it, you find where they intersect, you write down those points. Please check out the next videos if you want to learn how we can solve system of two equations by substitution or elimination. So let's talk about graphing. We are going to graph by hand one of them. To graph by hand this first one, we want to graph our linear function, which is x plus 2. And then we're going to graph our quadratic function, which is x squared plus 2. So we're going to graph both of those. I'm going to do this one in black here. So x plus 2, I go over to q, up 1 over 1. We kind of have this up 1 over 1 for our slope. We're going this way. And there we go. There is our line. Then with our blue one, we want to graph our quadratic. So we want to just plug some points in. I always like to start with 0. So 0 squared plus 2 times 0. Well, that's 0. So we have this point at 0, 0. 1 squared plus 2 times 1 is 3. So 1, 3. Oh, look, looks like 2 points cross there. And then let's try 2. 2 squared plus 2 times 2. Well, that's going to be 8. Okay, now I'm going to go the other way because that seems like that's about as high as we can fit on our graph. So if I put in negative 1 squared plus 2 times negative 1, we end up getting negative 1. So that's going to go right here. If I put in 2, we get 2 squared, negative 2 squared plus 2 times negative 2, which will give us a 0. And then we can see that it's repeated here. So this must be our axis of symmetry. And so then this will go here and here, and we can create our beautiful parabolic quadratic. Fantastic. Now, where are the two places where they intersect? Those are our solutions. Well, that's going to be right here and right there, if I could draw a line. Now, where those places intersect or our solutions, we're going to write them as points. So we have the point negative 2, 0 is one of them, and then our other point is 1, 3. And those are the two solutions to this system of equations. Now, that's a great way to do it if we want to graph it by hand. Another way that we can do it is we can graph it using something like Desmos. So that's what we're going to do here is we're going to graph using Desmos. So I am going to minimize this page here, and we are going to go to desmos.com. There we go. I'm going to drag it over here so that we can kind of look at both screens at the same time. Yes, this one is the one that I want. Perfect. Okay, so our graphing calculator, that's what we're going to do is graph it here in our graphing calculator. Now let's look at what happens. I want to type in both of these equations. Y equals 2x squared plus 5x minus 1. Fantastic. There is our quadratic. Our second equation is y equals x minus 3. Okay, now we can zoom in here and look. And by clicking on this dot, we can see where those two cross. And we can kind of click on the red one and say, oh, look, it crosses right here. Now, notice how these ones only cross in one place. When we're talking about solving systems by graphing, we kind of have three options here. We can either have two that never cross. There's no solutions. We can have two that cross in, maybe I can draw that. We can have two that'll cross in one place, like this. Or we can have one that crosses in two places. So just like when we solve quadratic equations, and they can either cross twice, they can cross once, or they cannot cross at all. Same thing happens when we're solving systems of equations. We can either have 0, 1, or 2 solutions. So in this case, we have one solution and our solution here, as we zoom in and click on that dot, is going to be the point -1, -4. So that's our solution for our equation. Now we can do that exact same thing again and again just by graphing in Desmos. So I'm going to do 3 more examples here just so that we can see what to do again. So remember, we're going to type these in. So y equals x squared plus 4x minus 4 puts us over here. Fantastic. And then our next ones, oh, that moved us. Then our next one is 2x minus 5. And boom, we can see that this one also only has one solution, and that is at -1, -7. That's their overlapping point. Now let's try these next 2 lines. So y equals -x plus 6 and -2x squared minus x plus 3. Okay, now let's zoom out. Oh, look, do you see how these ones never cross? Now these ones have no solutions or no real solutions. No real solutions. So again, we can talk in one of the other ways of how we could find those complex solutions, but in this case, and for the sake of our day, we are just going to stick with the real solution. So there are no real solutions to this one. Now our last problem here is going to, we have a fraction in there, but let's go ahead and graph these. So I've got y equals 3x minus 15. Okay, that brings us kind of low. And then our other line is y equals 1/2 x squared minus 2x minus 7. Okay, now looking at this one, we can see that that blue line goes through the middle, so it actually gives us 2 solutions here. So with our 2 solutions, we have this point down here, which is at 2, -9. There's one of our solutions, and our other solution in this case is going to be at the point 8, 9. So that is how you would solve nonlinear systems of equations by graphing. Again, we're going to graph both of them and figure out where they intersect. Please check out the next video to explore how we can solve nonlinear systems of equations using substitution or using elimination. Thanks.